Okay, good afternoon, good morning, everybody. Thank you for joining us today on IARC Solutions webinar series, EPM Cloud Wars. Azure versus OCI is our topic of the day. This morning, I'll be co-presenting with Jeff Henkel on my team, and we'll just kind of jump right into the session here. Okay, before we dig into our topics, I want to just kind of briefly show you folks some of the upcoming presentations we're looking at doing. We're trying to schedule these monthly as time allows, so you can always find out on our website the current list of upcoming topics as well as recordings for our past presentations. Oh, sorry about that. Okay, there we go. All right. So during the course of today's session, we're going to run through a handful of topics. We're going to spend a couple minutes doing a fast recap about what are cloud services. We're then going to jump into some technology terminology differences between Microsoft Azure and OCI cloud service offerings. We'll discuss some of our specifically surrounding Oracle EPM installation observations, as well as chat with you folks a little bit about some of the cloud considerations that might be useful for you as you plan either current or future architectures on the cloud. Finally, we're going to wrap up with some real-world results and cost comparisons between our experiences for Azure versus OCI. This presentation is a little bit different than we have in the past, where myself and Jeff will be co-presenting. So we're going to kind of teeter back and forth in some slides here. Anytime during the presentation, you can feel free to ask a question in the Q&A section. We will have a few polls here and there throughout the process. We'd love your feedback and answers. And like always, again, post your comments, questions. We love to hear these things and respond if we can. So I'll start. My name is Joe Malowicki. I'm founder and president of IARC Solutions. I'm a Oracle certified cloud architect professional. I've been doing this for, this is 23 years, more like 26 years, working within the technology and infra space. It's primarily focused around technologies that Oracle Hyperion has over the years been leveraging. In the last 4 or 5 years, I've been working with a lot of cloud architectural platforms, OCI, Azure, AWS, and Google Cloud. But I'm here today, again, just to kind of work with you folks and show you folks some of our experiences regarding these topics. Jeff, over to you.
Yep. Hi, everyone. I'm Jeff Henkel. I'm the practice lead for our managed services offering here at IARC Solutions. Much like Joe, I've been doing this for longer than I like to think about sometimes, so we're over 20 years in the Hyperion EPM space. I'm both an Azure and recently OCI certified architect. I've spoken at Kscope, done dozens of implementations from on-prem to cloud and hundreds of EPM implementations over the years. And as Joe said, we're going to kind of make this a back and forth dialogue on the slides, and you'll be kind of hearing from both of us throughout the presentation.
Thank you, Jeff. All right, so I'm not here to give a sales card or visit card about our company, but those of you who may not know who we are, or maybe the first time joining or working with us, our company, IARC Solutions, was founded about 8 years ago. We are we started our roots being primarily on-premise focused, dealing with the Oracle Hyperion EPM space. We've since sort of adopted and grown into a model of all things infrastructure, whether it be managed services or migration technologies, cloud architecture roadmap design. We have multiple certified architects, engineers on staff. All of our staff is onshore here in the US. We do 24/7 support offerings for customers, as well as critical care coverage periods. We have offices throughout the United States, Connecticut, Rhode Island, Mass, Indiana, Florida, and so on. But primarily we are a full services consulting services firm. And we do specialize in cloud technologies and infrastructure. Again, more information on our website, and any questions you might have about us, feel free to contact us afterward. The way we do our business at IARC Solutions is we put the customers first. And, you know, it's a nomenclature today to hear, oh, customers first and whatnot. But the reality is we have 100% track record of repeat business for our customers. When we work with somebody, we're going to hear from them again. And that's sort of our goal and our target of how we do things. I better do things, you know, to go above and beyond what customers require for particular engagements than to take a chance and shortcut and have to come back and ask for more money. So we're very upfront and honest with how we do our dealings. And again, you can see from our a short snippet of our logo slide here, we work with firms large and small. Before we get into the real good content of the presentation, just a little background about how we sort of fell into this cloud realm. We initially were, as I mentioned, more of a software infrastructure space type of a firm, and we've little by little transformed that into cloud-focused infrastructure. Okay, so we're one of the very few firms actually that embraces cloud infrastructure technology, especially with our roots being on-premise. Most technology firms are sort of scared to migrate to the cloud, but we're very, very big components of it and advocates of it, which is why we do have, as Jeff mentioned, certified staff on board for AWS, Azure, OCI, as many other third-party platforms and providers. And one of the big differences here is we actually use our tools daily. So we actually grow our business and run our business on all cloud infrastructure systems. All right, so kind of jumping right in here. I think, Jeff, we have a poll, right, for our first quick little
we do. And our first poll question is, what brings you to the OCI versus Azure webinar? So we'll pop that up. We'll give you 15 to 30 seconds to get all your feedback in, and then we'll talk about the results a little.
Yeah, most of the attendees. We'll give a few more seconds here for the poll. Okay. So taking a look here. So go ahead, Jeff. You can kind of run through this if you want to.
Sure, absolutely. So what brings us here today? 20% of us are here to learn new stuff. Over 50% of us are interested in cloud hosting with either Azure or OCI. Another 20% are just hosting somewhere else and interested in understanding what Azure and OCI might bring to the table. And one person is just out of new stuff to stream.
And I appreciate the honesty of that one person. Let's face it, we're all there right now after COVID. So thank you for being honest. Okay. All right, so let's just take a moment, just do a fast recap about cloud services in general. I think it's important to level set so that as you folks may or may not have questions about this presentation or future presentations, you have a good foundation and fundamental understanding. There's really three types of cloud services and technology today. You have what's IaaS, PaaS, and SaaS. So IaaS, which is infrastructure as a service, think of that as sort of your core building blocks. It's the nuts and bolts. It's the physical aspects, if you will, of any kind of data center or infrastructure or architecture, right? It includes things like the physical buildings, right? It includes the physical firewalls, if you will, servers and storage. A lot of those components are virtualized today at the networking, firewall, security, and servers and storage level. But think of IaaS as really the fundamental first building block. Oracle Cloud Infrastructure, Microsoft Azure, AWS, Google Cloud Provider, they're all very, very well-known examples and some of the top leading examples of providers of IaaS technology and platform support. We layer on top of that PaaS, or platform as a service. And this would be taking things like your operating systems, your databases, maybe some pre-canned application development tools and functions. You lay that on top of the IaaS foundation. Again, kind of a teetering model here. You're starting with the physical aspects, you're virtualizing, you're adding more and more layers of supportability, services, and solutions. So PaaS groups together that infrastructure and then puts on some of what's kind of called the middle tier, if you will, for your systems. Those of you who may be working within the Hyperion space now or in the past, think of this as your database tiers, if you will, right? Would be typical PaaS solutions from Microsoft or Oracle. The last piece of the puzzle for cloud services is called software as a service, okay, or SaaS. This is where you get into your hosted applications. SaaS could be something as commonplace as Office 365. It's probably the global, global footprint, if you will, a largest footprint globally of a SaaS-based tool. Office 365 is actually a SaaS application. It runs on top of PaaS, on top of IaaS, right? They're all teetered. This is how these things work. Okay, but you as end user or us as consumers only ever see, Outlook 365, okay, or webmail, if you will. Other tools like Salesforce, Quicken. So all these types of things. If you're Hyperion customers, EPM Cloud, or or Anaplan if you're not an Oracle customer. These are all solutions that are SaaS-based, but they always run on top of a PaaS and an IaaS infrastructure. Okay, so again, quick recap, just kind of explain to you where we kind of got here and how we kind of jumped into the process. All right, and I'm going to hand it over to Jeff for the next topic, and we can kind of get into our comparisons now.
Okay, so one of the things we wanted to make sure we kind of covered here and talked about a little bit is just some terminology and how the different vendors out there look at things. So, for example, when we start talking about OCI and we compare it to Azure, I'll be honest, having done a lot of cloud architecture, it's all pretty much the same stuff. The devil's obviously in the details, but at the end of the day, it comes down to finding like for like and understanding how each vendor implements them. So for example, when we talk about networking, right? Oracle calls it a virtual cloud network. Azure calls it a virtual network. When you talk about building a private connection between your on-premise data center and a cloud data center, Oracle calls that Fast Connect. Azure calls that Express Route. OCI calls a VM a compute instance virtual machine. Azure calls it a virtual machine. So you can kind of look at this slide and get that feel that everyone has kind of their own flavor and terminology about how things get implemented. But ultimately, you can pretty much build almost like for like across these various vendors. So, and that's what you'll see as we kind of go a little bit further along and we start talking about how we did these comparisons. You'll start to see that we got as close as we could, but there's always just that little bit of difference in the way the sauce is made. All right, let's go ahead and go to the next one.
Actually, one fast second. Was there a question from somebody on the group? I saw a hand raised. If so, you can type that in the chat if you'd like, or I can. Sorry, there you go. Was there a question? Someone had a hand raised? No? Okay, no problem. We'll kind of keep going here.
Okay. Okay, so again, if you want more information about this, here's a great URL. If you go out to the Oracle page, you can go to Cloud IaaS, Cloud Service Mapping, and it actually breaks this down across all the vendors. So we just kind of gave you a little flavor here for today's conversation about Azure versus OCI. But ultimately, you can go and find these various documents. It'll tell you, if I'm in AWS, right, what's the difference between an availability zone, a domain, and a availability domain. It's all kind of the same thing, okay? And then I'll talk a little bit about compute shapes in Azure. So Azure and OCI kind of implement the various virtual machine types a little bit differently. So with regards to Azure, they have basically 12 distinct series that you can go to this URL here at the bottom of the page. You can go and see which ones are which. Some are general purpose, some are memory leaning or compute leaning. They're better for storage or whatever that may be. You get a lot of flexibility in terms of, what your various needs are. You can, favor more CPU, you can favor more memory, you can favor more disk, or you can again use the general purpose that hits kind of all the sweet spots across those major components. And then the vCPU for them is basically based on, is equivalent to core count. So as Joe will talk about here in a minute about OCI, they do things a little bit differently. When you tell Azure, I want 8 for my core count or my vCPU, they're getting 8 cores when you go log into the operating system and look at what the task manager is actually showing you. Okay.
Great. Thanks, Jeff. So now taking a couple of seconds about OCI compute shapes, and just to level set, we're discussing these two topics in a little more detail, in particular because you'll see as we get into our analysis of comparison of performance and cost, it does ultimately come down to compute shape as one of the biggest driving factors. So on the Oracle Cloud Compute Platform, just like Azure, you have a lot of options as far as what you can and can't pick. Oracle does things a little bit different. They don't put them into a series necessarily, which I'm not sure the jury's out with good or bad to how to categorize that. They put them into basically types of instances. So you'll have things like your standard VMs or your disk IO VMs, right? You have bare metal servers, GPU driven, HPC, and so on. Obviously, Oracle being Oracle, it's the only platform to offer the Exadata options, which are, the fastest computing models you can get at basically at a cloud level today. But same thing, they kind of categorically put these parts and pieces together to give you a multitude of offerings to fit your workload needs. Now, unlike Azure, we have a lot of flexibility, as Jeff mentioned. You could actually pick, say, I want 2 CPUs if I want to, with X amount of memory in Azure and X amount of, and X amount of bandwidth. Oracle does a little differently here. Oracle scales everything based upon the OCPU count. Okay, so if you start normally with, say, for example, a 4 CPU compute node for Oracle, well, you're going to get 4 times the memory allocation. Normally it's 1:15 ratio, 60 gigabytes of memory. Okay, so if you get an 8 8 Oracle CPU count compute instance, you're going to get 120 gigabytes of memory. All right, and they scale the bandwidth and the disk IOP and speed based upon the size of the image you're actually working with. Okay, it's a little bit different. And in terms of how Azure does things. For purposes of this demonstration, we're going to go with what's called a VM standard 2.x, if you will. It's an Intel Xeon Platinum processor, and that's comparable to the Azure D series that Jeff mentioned previously. Okay. Final big tidbit about Oracle Compute Shapes and how it differs, as Jeff mentioned, from Azure or other providers is they use what are called Oracle CPUs. So in a virtual CPU model, you have a concept of a core, of a processing core, okay? And that core can have a number of threads, if you will, to go with it. Well, Oracle CPUs are a little bit different. They're actually reserved cores. And what happens is if you say reserve an 8-core OCPU image from Oracle, you're actually going to be getting 16 logical threads or logical cores. Okay, the term hyper-threading is often associated with this model. So you're basically saying the capacity is there to do more with those cores. So it is a little trickier than it used to be to compare one-to-one apples. And we did some testing on that, and we'll share our sort of findings a little bit as well. Okay. So then a really fast poll question today. I'm going to pop this out here. The big question right now for this one is, do you currently use a cloud provider today? We'll give another 5-6 seconds. Okay, so this is an interesting one. So we have a pretty even split between OCI and AWS for the poll today, about 23% each as far as results. A few folks are running with Azure. A couple of folks are thinking about it. A few folks, of course, are just SaaS-based, not OCI-based. But a really interesting concept is that a lot of folks aren't quite sure yet about this. That none of the above, this stuff isn't ready yet. And that's actually a very common theme we face. We do a lot of road mapping, architecture design conversations with customers, or advisory services, if you will. So you're not alone in your thought process and your concern. This is a very real question. It's something on everyone's mind. And again, we appreciate the feedback. And if we can answer questions as we go through, hopefully we can kind of help you guys jump into that next level of infrastructure. All right, Jeff. There you go.
Okay, so we did our testing with the latest and the greatest, and right now that's EPM 11.2.2, which dropped right as we were kind of in the process of planning out and designing this webinar series. So a couple things I wanted to talk about, and if you want some more information, you can reach out to us. I did a presentation on EPM 11.2.1 just a month ago. And one of the things I hadn't mentioned that's true both of 11.2.1 and 2.2, and that is this very first bullet point, which is vertical scaling is gone in the product suite. So for a long time, EPM supported this concept that if I wanted to have a really big server, right, I could have 3 instances of planning deployed on that box, and we'll call them planning 0, 1, and 2, and they could all run simultaneously on different ports, and the world would be great. EPM no longer supports that in 11.2.2. I'll be honest and let you know that I haven't tried it yet. When I have unlimited free time, I'll probably get out there and monkey around with that and see whether or not it's just not supported and works, or if it straight up doesn't work. So stay tuned for that. I'll at least do a blog one way or the other. Linux support's here now, so you can do OEL 7 or Red Hat 7. So that's new. IE11 is now deprecated. It's no longer supported with the suite. They're recommending that if you really want to use a Microsoft browser, that you move to Edge. And last but not least, Oracle DB19C is now certified on this latest release. And talking about some things that we noticed here, and Joe, feel free to chime in on these slides too if I missed anything, but we've got some quirks, right? The way things get done in Azure and OCI, as we mentioned earlier, are a little bit different. So on the Azure side, the first thing I noticed is the faster CPU clock. So as a general rule of thumb, even though we tried to get the same processor like for like, the clock speeds are a little bit higher, it seems, across Azure. Inbound rule sets. So when you create a new image and you just do a quick deploy, all of the rules to RDP into the box and all that stuff are kindly automatically set for you by Azure if you allow it to check the box. So on the same token, the RDP is also available for you to download. Of slightly more interest is the fact that if you don't do a bring your own license to Azure, then you're going to get Windows Data Center, whichever flavor you pick. We picked 2019. And as Joe will show you in later slides, there's a cost choice, or a cost impact, I should say, associated with that. You get default DNS set out of the box for the image or images you build. You can pre-select your time zone instead of getting pushed into UTC. And you have the ability at build to do an auto shutdown. Joe, you want to talk about the Oracle ones?
Absolutely. Thanks, Jeff. And actually, and as Jeff did mention too, just kind of preface how we did this. We literally took and built these two images side by side, and we stepped through the entire process, all painful as it was, of a complete, starting to build a compute shape, to deploying the compute shape, to installing and configuring all the software and doing some testing. So we really tried to mirror side by side for our purposes here. So, whereas Azure offers up definitely faster CPU clocks for the same chipset level, if you will. The flip side of the house, Oracle is offering out of the box 2 times larger boot volumes. So I think we had 125 gigabytes, give or take, of boot volume was the default option for Azure, while Oracle's giving you 250 plus as a standard. Okay, and boot volumes for Oracle are not charged for. They don't charge you for storage by any means. I believe the same thing for Azure. Memory, as I briefly mentioned before, it's a 15:1 ratio, so a lot more memory. One of the problems we had was finding an image shape in Azure that could handle the entire EPM stack for our quick side-by-side test over the last couple of weeks. Well, basically, even the smallest image size from Oracle, a 4-core model is going to have plenty of capacity. So, but we had to actually wind up getting a machine that had 120 gig of RAM just to get that's the smallest size we can get to fit the same core capacity as the Azure boxes. Okay. There is no default administrator. There is a default admin predefined for any Oracle shapes. So in the Azure world, you kind of pick and choose, type your own name in for your default administrator and password. The way it works in Oracle is they create an OPC account, it's called, for any Linux or Windows images, and that will get assigned a temporary password, random, which you cannot change default. After you log on the first time, you're required to modify it, but up front you can't. And as silly as that sounds, these passwords are not easy to copy and paste. You have to type them by hand. So DNS default's not set. This was a big one when it came to EPM stack. We found was we'd fired up ran our installation program for Hyperion or EPM, and the first screen that popped up was an IP address and a big warning saying, hey, there's no DNS name set for this host. So out of the box, Azure had no problem with that. Picked up its really long DNS name, virtual or not, but it worked. Oracle, the OCI, we had to actually go out there and set the default DNS. In our case, we created a local host file to accomplish that. This next one, the default power turn down. This is an odd one to me. It's just some generic customizations in the Windows operating system that Oracle chose to do. It's on balanced power as opposed to high performance power. Again, a little thing you have to tweak afterward. And the last one was one which is very interesting. When you spin up an OCI compute instance, regardless of the type of it, you are picking a availability domain and a fault domain, as you'll hear in a couple minutes. Well, that's pinned. It's not moving. It's staying where it is. The Azure one at one point, Jeff, right? It kind of changed over the course of a weekend or restart, and all of a sudden we had a different shape. Different hardware for the CPU. as what I recall us saying. So that was an interesting concept that we saw when it came to Oracle Cloud. So taking a minute to kind of discuss a couple of what we kind of call the cloud infrastructure design considerations. So one of the benefits of any cloud platform is that you're paying a metered service, right? And you're paying a metered service, and it's kind of like an a la carte at a menu restaurant. You kind of pick and choose what you want. You can get as much or little of each thing as you want to get your hands on. Difference is you, as opposed to a buffet, if you will, is you pay as you go, right? The more you get, the more you pay. Well, there's a lot of technology that these cloud providers have built into their infrastructure and their solution offerings that you may be able to leverage when it comes to deploying specifically Hyperion, but in generally speaking, any kind of new solution. So as Jeff mentioned earlier, a lot of them do the same thing. You know, a few of the big points that we always talk to customers about is your first and foremost is connectivity. You know, they offer multiple options to get to the cloud. Remember, a cloud infrastructure is just someone else's data center, right? Whether it be Amazon or OCI or Azure or Joe's backyard garage server farm, right? It's still someone else's data center. So when it comes to connectivity, all of them offer what's called internet public connectivity, right? You set up a server, you turn it online, you got your website available to you, or you can RDP to it, or you can shell over to it with a secure connection. That's not really secure. You're over the public internet. Even if you're encrypting traffic, you're still traversing the public internet. Next option would be VPN tunnels, right? Which is sort of your first layer. VPN tunnels are great in cloud infrastructure for POCs, development environments, possibly DR access. Okay. I don't know, Jeff, if Azure charges for VPN tunnels or not. I know OCI is free. I don't know. Do you recall if Azure charges for VPN?
I'm pretty sure the VPN tunnels are free. You have to charge it when you get to the next level.
Yep, there you go. Great. The next level, part of the typo here, you have Azure Express Route, not Connect, and you have OCI Fast Connect. This is like a dedicated connection. And the way this works, you can kind of see this picture on the bottom side there is your Azure Express Route, you know, or your Oracle Fast Connect. These are basically how you link to cloud infrastructure for Azure or OCI, okay? It's a dedicated pipe. It's as if you're on the same network. Obviously, the cost comes into play when you get to that point, but that's how most customers wind up doing a live or production, scale migration to cloud connectivity, all right? Both providers offer a series of database services, which are kind of PaaS services. Back to our very first couple slides, PaaS is basically infrastructure as a service, your hardware, storage, networking, and tacking on now some stuff, in this case, databases. Now, out of the box, if you read the, technically speaking, Azure SQL Server database service is not technically supported right now by Hyperion EPM, okay? But the jury's out on that one. There's a lot of bugs and SRs enhancements. We can tell you it works. Should you or should you not use it? Again, it's one of these things where over time, I think you'll see that get blessed and approved as an actual SQL Server offering. Oracle database, however, being the fact that it's Oracle, right? They do support their Oracle Database Cloud Services PaaS offering, okay? Now, I mentioned this as an option because you have the concept of, well, I can set up my own Oracle database server, my own SQL server, and I can install my own licenses on it. I can do my own configuration of it. That's all great. But using these PaaS database platforms, it takes away the management aspects and the infrastructure aspects of maintaining those things. So there's a lot of good reasons to consider using the PaaS database services wherever they're supported with the Hyperion stack or any stack for that matter. I do want to call out that today Oracle has two autonomous database offerings. They have an ATP or transaction processing and an ADW data warehouse. Those are currently not yet supported for Hyperion purposes. There are some bugs and defects and enhancements out there that I know I've personally requested for some customers. It's coming. So they are working on ATP support. It's just not there yet. Okay. When that comes out, I think it's going to be a game changer for a lot of costs for customers, because those databases scale up and scale down automatically based upon usage. So you're not going to be paying for your 32 cores of database services, right? If you're never using them, you only pay for what's being consumed. Last two pieces that I wanted to throw at you is Azure and OCI. We're doing this presentation for more than just a marketing spin. There's also a very, very collaborative and very public work model with Oracle and Microsoft. I'm sure it's to knock Amazon, of course, in the end, but they have come to a lot of agreements. And two of the big agreements they have put in place today is the idea of using this thing called Azure OCI Interconnect. And what that is, it's allowing customers to basically attach any Azure offered services to any OCI offered services through direct conduits, through Express Routes and Fast Connect. Okay, so if you're a customer who is running Oracle EPM, for example, on premise, but you want to use Azure SQL Server hosted, right? You don't have to go through the public internet. You can get a direct connect established, to get over and use your SQL Server on Oracle side. Likewise, for Microsoft customers who want to host and run EPM, but they want to use Oracle database cloud services, again, you can get direct connects. You're basically getting the benefit of both data centers and both infrastructure technology offerings through direct connections. You don't have to worry about going through your on-premise or over the internet traversing. Okay, it's a fantastic new model. It's very, very, very large customers are actually doing this today and using it. It's fantastic. And the last piece is something which we always tell customers consider is you have the concept of a federation of accounts. You can actually take and use your Microsoft AD or Azure AD accounts or any SAML 2 compliant providers, and you can use that for OCI. So you don't have to create manual logins for your OCI console command line over and over and over. Over to you, Jeff.
All right, so a couple of the things we wanted to definitely touch on about cloud in general and OCI and Azure in particular is really this concept of high availability in the cloud, which is important to separate from DR, which we'll talk about here in just a second. So high availability is a concept that within a given environment, production, dev, test, QA, you have some resiliency or redundancy built into that environment. So when you're deploying in the cloud, right? In Oracle, we call them availability domains. In the Microsoft Azure side, they're called zones, but they're essentially the same thing. And it's this concept that in any given region or location, so for example, US East, you're going to have 3 availability domains or zones that are physical hardware zones or stacks that are completely separate for all things, power, network, hardware, server hardware, etc. So that's the first thing to keep in mind. Now, some regions in OCI only have 1 availability domain, and some Azure locations only have 1 or 2 zones. So it's always important to look at the written material and understand, where you're at. Typically, the major geographical regions in the US, Europe, and APAC all have the full stack. But sometimes when you get to some of the what I'll call smaller geographical areas or more recent additions, will have less zones available to them. And then within those zones, any given zone, you'll typically have availability sets or fault domains. So these are racks, if you will, within a given data center that are also redundant hardware for power and networking, so that you can spread your compute across those different sets or domains or racks, however you want to think of them, to ensure that within a given environment, within a given domain, you still have highly available servicing to whatever your EPM requests may be. And then one thing that's a little bit different between OCI and Azure is this concept of an update domain. So an update domain is something that Azure has put in place so that you have different domains for patching and maintenance of the Windows operating system or application operating system. So you can spread your servers across those, and then you can automate your patching, your updates, and all that stuff. And then they will only take the servers out of service that are within those specific update domains. So that's kind of a, if you will, a logical management of your environment that does touch on high availability, but really doesn't address what high availability is truly thought of when most people talk about it, which is an outage of some sort. All right. And then OCI has been kind enough to provide us with some architecture diagrams, and Azure, I should say, has very similar diagrams available, though not necessarily EPM specific. These are nice because they focus on the Hyperion EPM suite. And if you look here at the one on the left, right, this is a pretty straightforward look at what an architecture would look like if you only had one availability domain available or only chose to deploy to one availability domain. And this is a pretty detailed diagram. You can find this out on the web. But essentially what you're really looking at here, right, is I've got a subnet that goes across a couple fault domains. And in that, those subnets, I've deployed individual instances of all my various EPM products. So whether that's Foundation or Essbase or HFM or whatever that is. And then I've also got database nodes that live in those individual fault domains. And essentially, right, I've got all my public networking that then connects to bring my users in. Now that could be like a fast connect if I'm bridging data centers, or it could be a VPN IPsec type connection where folks are just VPNing right into the cloud provider and then getting connected. Joe, you want to talk a little bit about the second piece?
Yeah, absolutely. Thanks, Jeff. Yeah. So as Jeff mentioned, yeah, these are publicly available from Oracle. And first off, I want to say, man, I wish I was a salesperson selling this architecture to anybody, because it would just be a great commission check. In all my years, we don't have too many clients that would be this intricate as far as owning every piece of the puzzle. But yeah, as Jeff mentioned, these are really designed to be sample high availability deployment designs. Okay. And yes, the left side, as mentioned, a single AD model. We're using fault domains for the high availability or fault tolerance. And the right-hand side, it's taking and spanning it across availability domains. So you have two within one particular region. And again, recapping, a region is a physical area in a country or a world, if you will. An availability domain or a zone, if you will, is a set of fault domains or domain servers and hardware. So they're still geographically dispersed in your same region. And that's what this model uses. They're using basically within one region, the idea of splitting and an availability domain, to kind of put it in context, could be across the city. You could be 35, 40 miles. They actually do have spec'd out distances that are between these actual ADs. But you can see the differences between the left and right side is within one AD, things are constantly being shared. It's active all the time between your two fault domains. Whereas in the second model on the right-hand side, one set of servers is basically in a standby mode. It's in a passive mode. And you're using a series of rsync, data guard, other types of tools for syncing up your data file systems and whatnot between your primary and your standby. In the event something blows up on you, you simply flip on the switch. Virtually, it's not a physical switch, obviously, and traffic is then served over to your second availability domain. Okay, so again, what's nice about these designs is Oracle did put together a full article blog right up on how to deploy this stuff. They even give you Terraform scripts. We're not getting too geeky right now in this presentation, but you simply could load a Terraform script up, assign new names, push a button, and start getting built by Oracle for either of these architectures if you want to. All right, Jeff, over to you.
Yep. Okay, so this is kind of a concept that we thought about. So one of the big benefits of the cloud that everyone always talks about is this idea of auto scaling, right? I can have a node of something and I put some parameters for monitoring around it and say, if I hit 75% of my CPU, right, spin me up a new node. That works great where all things are equal, right? My server 1 looks like my server 2 looks like my server 3. The EPM world doesn't work that way. All of us who've done installations on it are familiar with it, know that there's this concept called the registry, and I've got the database layer where a lot of that stuff kind of is hard coded. So I can't just auto spin up a new node and hope things work. So instead, what I think I would do in that scenario is I can spin up as many nodes and install them in EPM as I really want to, right? So in this diagram here, I've spun up and installed 4 nodes. During my normal workload, I've shut down 2 of those nodes because I don't need them from a capacity perspective. It's not month-end close, or it's not the planning cycle, or whatever that is. So all of the things that are kind of in this dark orange are running every day. I have to have my database and Essbase and a couple nodes. But I can put monitoring around that. And then in the event that I do hit that 75% CPU threshold, I can spin up that 3rd and or 4th or 5th or 6th or whatever nodes and bring those systems online. The upside to that is that from a billing perspective, right, I'm paying for the storage capacity all the time. So that's kind of a negative. But the positive is I'm not paying for the compute, which is usually where the dollars tend to come in a little bit more. So this is kind of a model you could think of deploying in your environment. And it's certainly something we're going to be experimenting more with in all the providers as time goes on.
Great. So taking a quick moment about DR in the cloud. Again, we have a whole presentation coming up later on this fall regarding actually deploying DR solutions just in cloud-based focuses. But some common principles or technologies in play. The concept is to architect across regions, meaning you want to use geographically dispersed locations for your disaster recovery. To clarify HA and DR, HA means you're mitigating or remediating single points of failure, okay? Disaster recovery or DR, defining that means I am experiencing a catastrophic geographic event where I have a complete outage, not a partial outage. So the goal behind DR is to make sure that everything is replicated in sync and has definable SLAs to be brought back online within those definable SLAs, okay, to ensure you have business continuity. Right. So typically for any cloud provider platform, Azure or OCI, you do concepts of backup replication and copying as well as block and volume object replication. So that slide a few minutes ago, we had all the little boxes sitting out there. Well, all those boxes had underlying storage. You basically would replicate the entire disk level or block volume, they call it, under the hood, the image itself over to your DR site normally is how that's done within the cloud and infrastructure providers. Okay. You'd have to have things like different DNS or traffic management in play. You know, OCI calls it DNS zone management or traffic steering. Azure calls it DNS and traffic manager, the same kind of concept. Something monitoring traffic and saying, well, in the event region 1 goes down, I can shift over to region 2 simultaneously. And there are ideas of active-active, active-passive, all kinds of scenarios you can build depending upon your business continuity requirements and your SLAs. But the goal is to replicate across regions, not to have an actively serving traffic split system. All right. When it comes to databases, you know, again, talking about Oracle or SQL Server, you have things like DataGuard and Golden Gate from Oracle, which are tools commonly used along with rsync to replicate data across different regions, whether it be your on-premise site and using OCI as an example, very, very common. A lot of folks are using, if they're Oracle database customers, they'll have tools like DataGuard and Golden Gate being leveraged to their on-premise data center, and they're using OCI only for DR purposes. Right? Same thing for SQL Server and Azure. You have log shipping and always on cluster. So technology is there. And DR, again, is a loaded question. It's a loaded topic, which we're definitely dive more into in a future series of webinars. But it's something which you should understand that the Oracle Cloud as well as Azure Cloud were built for DR purposes to take a lot of that legwork out of the picture for you folks. Okay, I'm sorry. So next poll question. Now, sorry, the good stuff now, right? We're down to the kind of last 15 minutes here. I apologize with a ton of clock taken away here. I want to do one more fast poll. We're going to talk about now basically about performance and cost, okay? And this is using some real world statistics that we actually did in our own labs to kind of compare some of these things. So one more fast poll. We'll spend another 10, 15 seconds. And this one is the fast one. It's a 1, 2, 3 choice here. The goal here is which provider do you think will win the performance battle head to head, Azure or OCI, with EPM in the mix, to qualify and clarify that. A few more seconds for this one. Okay, all right, so our results. So overwhelmingly, you folks think that OCI is going to be the head-to-head winner when it comes to performance battle. From an EPM perspective, we had about 54% at OCI, 31% Azure, and then 15% of you just are not lovers of either Microsoft or Oracle, and you went with Google or Amazon. Okay, so let's kind of jump right in here. And Jeff, do you want to share some of the results of these guys and let them know what we tested and how we tested things?
Yep. So just a little bit real quick before we actually talk about the numbers. You know, as we said, our goal was to size these things as closely as we could get with some of the standard image options that we have available. So in the case of Azure, right, we went the D5 V2. with 16 CPUs, which is very comparable to the OCI VM standard 2.8 with its 8 OCPUs, which are truly hyper-threaded. So we're looking at 16 to 16. As we noted, we didn't have a lot of ability to massage the clock speed in the OCI world. So we got a slightly faster clock in the Azure world. We also couldn't really get an image that was 16 CPU and 120 gigs of memory in Azure. To get that combination, we actually had to bump up to 32 CPUs, and it sort of became this never-ending game of trying to chase the vast amount of RAM that OCI is willing to give you versus trying to monitor or balance out the CPUs. So we ended up with twice as much RAM in the Oracle world, but we didn't tune to that. So in other words, we're all using out of the box tuning. So it probably didn't really benefit the suite much in any fashion whatsoever. And then disk is kind of disk. So let's go ahead and go on to the next slide and talk about some numbers. So here's kind of how it panned out. We looked at a number of different things. From the top bracket is really all about how the product behaves in just basic installation and configuration. And what you'll see over these numbers is that any activity that was really disk bound, so the unzipping of the software, the installation of the base software, tended to benefit OCI. They have faster base level disk storage IOPS that they're handing out with their images compared to Azure. Now, you can certainly upscale the number of IOPS you're getting in Azure by the image selection and by selecting premium disk and doing some other things. But at the end of the day, cost, $1 being equal, OCI's got a pretty hefty 25% lead there. What you'll also notice, looking both at the installation tasks and then at the Essbase aggregation and HFM record retrieval and consolidation tasks we did down below, is that there is some benefit to be spoken of in regards to having the faster clock speed and being able to massage, select, and architect by choice the clock speed you want to see. So there you start to see 10, 20% better performance, especially in HFM, where that clock speed starts to pay off in the way your data calculates up.
If I could pause 1 second, there were two fast questions on this slide. So first off, all these numbers you see here are actually in seconds. We calculated back to the second, okay? So yes, across the board second. And the third column with the winning percent patch is basically the delta difference, right? So for example, the multiple iteration Essbase aggregation, right? There was a 3% benefit to running OCI over Azure. That makes sense. Yep. Sorry, Jeff.
Yeah, no problem.
So if I could add two quick things to point about this slide, then we jump onto the costing next here. First off, I wanted to shout out one of our actual clients. I actually see him on the webinar today. Actually gave us this great little speed test tool for the Essbase aggregation speed, okay, which is a fantastic little thank you to that person. You know who you are. Appreciate that. And again, we tried to make this as real world as possible, where you see things like configure foundation services. Well, we did multiple components we configured, obviously, in nodes. They're all relatively the same, whether we're deploying the planning piece or FDME or foundation, they all were relatively close. So we didn't want to put out there every single one of our metrics. Okay, but these were iterative testing, it was multiple testing, and these actually were the real numbers that kind of came in the process. Okay. All right, so we're going to jump in because we're getting down to the wire of the hour here right now. We're going to jump into one more quick poll question, right? What does all this cost and how it's compared? Oh, I'm sorry. So to sum it up, as Jeff mentioned, right, when it comes to CPU performance, right, it sounds like Azure is the sort of the way to go, if you will, to the clock speeds, and it comes to storage, kind of teetering more towards OCI. All right. So one last fast poll question we're going to throw at you guys, and this is my favorite here. Who do you think will win the cost battle, Azure or OCI, as far as being most cost competitive? And this is great because this is where I see everybody's budgets and where they're coming in from and what people actually think or believe is true or not true based upon the hype. We're going to give us a couple more seconds for this one. All right. So the results are in. So on the forum today, it looks like about a third of you think that OCI is going to be the most cost beneficial or win the cost battle, if you will. Azure seems to be the far out winner at 40%. And then there's still a solid, hanging on by a thread, 27%, thinking that's going to be Google or Amazon if you're comparing apples to apples as far as hardware. So let's jump in here. Before we give you the actual real numbers, one thing I want to quickly point out to you is if you want to price out infrastructure as a service offerings for OCI or for Azure, both their websites have great calculators out there, workload estimators from Oracle as well as cost estimators. And the same thing for Azure pricing calculators. You can be extremely detailed as far as how you want to spec these things out. They can be overwhelming at first. So if you have any questions on how to use those things, you're more than welcome you're more than welcome to ask us. We'll be happy to kind of, give you a hand kind of using those tools. And we will talk about in a couple of seconds, one of the big things Jeff and I noticed recently as we're costing out this infrastructure. Before I jump into that, there was one question about the performance comparisons. The question was, were we using OCI installed SQL Server or using database cloud service? We wanted to compare truly one-to-one. So for our model, we did a single server model with everything installed locally. So we truly were comparing one-to-one. We didn't want database technology to be a factor as far as splitting it out. We wanted to say, all right, one box, apples to apples. So we actually used our own licensed SQL Server 2016 installation on each of these two servers. We didn't do an Oracle one for comparison's sake for this particular demo. All right, so pricing. We're going to start out with pricing. We costed out 4 different models: a micro, a small, a medium, and a large environment. Okay, I'm not going to read through all 4 slides, but all 4 slides are in this deck. We'll kind of skim through quickly here, but we want to start out with basically showing you what we were playing with today. So if we look at what we use for our particular testing purposes, you can see based upon a monthly cost and annual cost, what you're looking at doing. The exact same equipment that we spec'd out and used for you today. Right. Unfortunately, those who chose Azure, you're a little bit off on this one. You can see the dramatic cost differences, right? The Azure monthly cost for a single node that we were using for our tests is about $713 a month with the Windows license included, data center license included, versus the Oracle standard shape image, which is about $449. So about a 36.7% difference in price right there along on the actual compute instances. The big jump, as you're going to see when you're comparing OCI, Azure, and the rest of the vendors, it's on networking. Okay, Oracle tends to almost give away the networking aspects. They give first 10 terabytes of egress. That means external or exiting traffic from OCI for free monthly. 10 terabytes is dramatic. You can see 10 terabytes of egress on Azure is going to cost you $1,300 a month. Okay. So major difference when it comes to how Oracle prices things out. If you back out the networking, again, about 37% difference in price. Once you back in the required networking, load balancers and traffic and whatnot, and if you compare apples to apples, you can see you're almost 75% more to go with Azure over OCI monthly, okay? And we took this model and we simply scaled it up a couple more times to kind of give you guys an idea. A small environment for a Hyperion operating system with possibly a couple servers, right? No HA, no DR. Again, here are some numbers you're looking at. Bottom line, you're looking at a monthly cost of $2,700 versus $940, and looking at almost 2 times the cost of an annual rate once you start scaling these things up, okay? Jumping ahead to, we'll kind of go into a large environment, so we have some time for questions at the end here. A large environment will be something which, we deployed recently for several customers this size, talking about possibly 8 different Oracle EPM servers, application servers built in a HA configuration. So 2 nodes of each thing, if you will. These particular configurations don't take into consideration database license costs. This is simply just the compute instance and hardware and software on those servers, as well as your networking and storage components required. These large environments also would assume you have something like an actual DR site in a different region, okay? Hence you have 2 block storage volumes because it has replicated across for your shared, for your storage interfaces, or 2 load balancers, 1 in each region. Load balancers typically are automatically scaled for free anyway within each region locally, but for redundancy, but when it comes to different regions, you're spinning up 2 of them. So that's where you get your 16 servers, if you will, 8 in region 1, 8 in region 2. And you can see the cost difference here, right? This is an annual cost of hardware, okay? So this is not taking consideration fast connect and all those parts and pieces to go with it. So ultimately, when it comes down to it, OCI technically is the cheaper platform to go with, okay? When it comes to actual hardware hosting costs. So Jeff, how about in summary? Let's kind of run through a couple points in summary here, and if there's any more questions we can answer.
Sure. Yep. So in summary, flexibility in compute shape is really kind of comparable. As I mentioned, you can do a little more massaging in the Azure side, but you pay for that in terms of this memory allocation on the third line. CPU performance is a little better in Azure. Storage is definitely a little better in OCI right out of the gate. Database offerings are pretty comparable, as is the ease of deployment. They're really pretty intuitive to stand things up in these cloud environments, and that's what you're paying for, right? It's a lot easier to stand up a VM than it is for me to install a VM host and then get that licensed and then build a VM on top of it and install my own OS and all that good stuff. So these are quick and painless. The Windows config in Azure is pretty painless, but the OCI Linux config is much more painless because of OEL and the way they're used to deploying and managing a lot of their own infrastructure on Linux. Networking, the nod goes to OCI more on the costing. They're both easy to configure, the various networking layers, but in Azure, right, you have 2 layers of load balancer you really have available. So you've got a level 7 and a level 4, and you have to know which one you're going to use for the traffic you want to manage. Whereas in OCI, you really just have kind of the level 7 one that's assuming both roles. Makes it a little bit easier. Console administration, they both navigate just fine. They're individual, but you can find whatever it is you're looking for, great search features, etc. But it really all comes down to, if you're truly making a financial decision, without any licensing agreements, negotiations, or any of that kind of stuff, I would tend to lean towards OCI being a lot cheaper, and one of the biggest kind of tipping points being that networking aspect of it.
Yep. Thank you. Yep. So as we wrap it up here, I want to kind of throw out 2 quick things here for you folks. And again, feel free to ask any questions you folks might have. We'll be happy to answer them live right now, or in the chat, live in the session, even after, of course. But I wanted to kind of mention 2 quick things. If anybody is interested on this web session, or other folks you might know who actually want to test drive or check out, if you will, running Hyperion on one of the providers, we actually do have a series of sandbox and demo and POC environments available for use, kind of a sign out kind of concept, a library card. So just send us a fast note, and then we can get one turned on and spun up for you. It'll be available via the internet, via web URLs, secure URLs, and you can jump out there and play your heart's content. So you can see the latest and greatest 11.2, and you can even try things with fully baked apps that we have out there running on OCI or Azure. Okay, it's the first thing. And the last piece of tidbit is, since we're talking about comparing different cloud providers, there is a blog out there called Cloud Wars, and that's not my blog, unfortunately, by Bob Evans. He's actually an old Oracle executive, and he began writing this blog several years ago. It's something which I use on a regular basis to truly get non-biased information about all the cloud providers. He's great about laying the facts out there, avoiding opinions, just kind of comparing apples to apples. So if you haven't seen his blog before, Bob Evans, a great guy. I added him on LinkedIn, asked if I can give a shout out. I was surprised he actually responded back and said, absolutely, feel free. It's a great resource to kind of check out. So we're at the top of the hour, but there are a couple more questions here, and I want to see if we can answer these for you. So I think, let's see, where'd that last question go? Oh, you answered that one, Jeff. Sorry. Okay. Yeah, there was a couple questions here. We use 2.3 gigahertz CPUs for HFM app servers and OCI. The 2 gigahertz were slow. Yeah, it all depends on which model you're working with. And actually, regarding CPU performance, I did open an SR with Oracle recently regarding this. Say, hey, what are my options here? I got my 2 gigahertz processors for my Intel Xeons. I'm comparing to Azure, AWS, and whatnot. They actually came back with an interesting recommendation to begin using the OCI AMD processor image shapes, the E series shapes they call them. So I haven't tried that personally yet, because I've always taken the E series shapes as being sort of the non-commercial level quality. as far as consistency, but in doing some more homework and research, they do get your burstable speeds 3 gigahertz. So we might do some more testing on that and kind of give our results and put them on our blog as well. Any more questions anybody has out there today? And again, if you're welcome to ask now if you want to, pop into chat, into the Q&A section, or if you'd like, you can email us afterwards. Our contact details up on the page here, so feel free to reach out. We'll have this recording on our website as well as our YouTube channel, which you can grab. Again, if there's no more questions, we thank you. Oh, here we go. How did you find 11.2 deployment versus documentation? Oh, generally speaking. So Jeff, you can answer that one. What are your thoughts? 11.2 deployments versus documentation, like reality versus written doc.
So if you're doing a standalone node, the reality pretty well matches the documentation. Where it gets fun is in the real world, where once you start doing a distributed deployment, I've found a couple of times that you have to do some things that aren't in the documentation. So in that scenario, I highly recommend you look on our YouTube page or our webpage, find the presentation that I did specifically on installing EPM 11.2.1, which is exactly like 11.2.2 as far as I'm concerned, and follow some of the recommendations in there. There are certainly some things you have to customize that they don't mention in the documentation. So it's mostly there. It's better than previous releases. I'll give it that.
Good question. Thank you, Jeff.
Yep.
Anything else? And again, we're not going anywhere. You folks can always send us questions by email if you'd like. Feel free. We don't charge to talk. So, any questions you have, email us, contact us, text us, social media, whatever. We're here for you. We thank you for your time today. And kind of bearing with us in our first sort of a joint back and forth presentation. Again, I hope you all have a wonderful, safe afternoon or morning if you're in West Coast based, and we'll look forward to hopefully speak with some of you folks that are on. Thanks again.
Thank you.